I'm really serious about this. We need to get serious about real-time communication. If you've seen my presentation in the past, they're filled with nice pictures for those of you who don't want to listen to content. Today, I have no nice pictures. Because I really want you to take the Johansson challenge, in addition to the Matt Jordan challenge, and get serious about what we're doing. So we need to focus on what we really are talking about when we talk about real-time communication. And there's just a few things that is important, right? It's here, it's now, and it's together. We have multiple parties communicating in real time. And that really changes the picture if you compare with other applications like email or Jabber or other things. We're really real time. And things have changed during 10 years of Astricons and more than 10 years of Asterisk. And we've been lazy. So what I want to do is to really give you a to-do list. And since I'm getting old, I can't remember a lot of things. So it will be a very short to-do list. But next year I'm coming back. I will check up on every one of you that you actually follow the list. Are we in agreement? Okay. I'm between you and the coffee break. So listen up so we can move this fast, because I have tons of pictures. I have 2 weeks of presentations. If you do not get it, we will get food. We will happen. Please lock the doors. Asterisk is kind of cool. We're in the bullseye and have been for 10 years between many different developments. The whole thing between telecom and datacom, moving from the old-fashioned ISDN to real-time IP communication protocols. We've been in the middle. And that's been a really cool time. One area where we really need to look into and sharpen up is the transition from trusting the old telcos to trusting ourselves and building our own solutions for trust. We gave the world Asterisk, and that was great. We really loved the product, we loved the software, working together, meeting all of you, and they started using it. Oh no, what happened? Asterisk is everywhere. People with no formal training in SIP protocol started using the software. Gosh. And we built it in one way. We kind of thought of one usage. But that has changed. Every single installation I work with is internet facing, right? Asterisk connects to the internet, communicates directly with the internet. 10 years ago, 12 years ago, we were hooking up to SAP with SAPTEL, with ISDN, with the phone system, and used IP side for connecting phones on a private virtual network. That's not the case anymore. Especially with WebRTC and new channel drivers, we're going to face the internet much more. And this will affect how we build and design systems. And Matt, we have things to do. Asterisk is now an internet real-time communication platform. But it's not designed that way. People are still allowed to install with extension 4000, username 4000, and password 4000 on an internet-facing machine using insecure protocols over the internet, because it's cool, it's sexy. I mean, the users, I've been working with this for 10 years with quite a lot of projects that never ever required security because they trusted us to deliver. Like they trusted the telco to deliver a secure solution. They trusted us to build systems that protect their integrity, privacy, and the right to have confidentiality in their conversations. They trusted us, but we failed. We failed miserably. We need to sharpen up. And it's so fun standing here, not as a representative of a company that sells you stuff, because I can sell. But you guys failed. We're doing a miserable job, all of us. And considering what has been revealed, we really need to sharpen up. We need to fix this before they really discover what we did to them. And we have a very, very short window of opportunity to cover up. They will discover what happened, what we did. And the tools are all there. They are in Asterisk. We have TLS, we have SRTP, and we're coming up with support for DNSSEC, DANE Trust. There's nothing new in all these tools, but no one was really interested in them. When I talk about DNSSEC, they say, oh, we don't need that. Everyone trusts it. When I talk about TLS in the telco business, I run tests, I zip it. They don't understand the basics. I set up a test with 6 different servers. 5 of them had failed certificates. Certificates from hell, certificates from the future, expired certificates, wrong names. And people come up to me and say, really good test. I succeeded to get a lock on my phone on every single one. This is not good enough. We need to start using them. The users will not ask for it. They trust that it's all there. We just need to enable it and get running. Because this enables so much more if we can trust the real-time communication. Are you ready for bullet number 1 on your to-do list? Do you have pen and paper? Or digital stuff, computers or phones that you trust? Okay, here's to-do number 1. Always build secure platforms. Regardless what your customer or your company say, secure all communication by default. Okay, one thing to remember. Let's move on. When we started working with IP telephony, we came to office networks with an IP PBX. And the network guys told me that, yeah, well, great. I mean, we have a state-of-the-art network. This is really, really going to take it all. And we were starting to run 100 packets per second per call, and the network broke down. It wasn't really built for real time. It was built for store and forward, fetching web pages, SQL queries, email. But real-time communication, I still, in every call center installation, I have to act as a mean guy and break down the firewall guys because they tell me, oh, you know, we can handle 100 megabit wire speed. I keep telling them, this is not about 100 megabit wire speed. We're going to force 500 calls with 100 packets per second through your firewall. Can you take that? Oh, yeah, we can take that. A moment later, when I actually do it, they cry, machines crashing, bad things happening. But this was a long time ago. The networks now are built for real-time communication, and the internet connections is also built for real-time communication. We can do new things. Why? Why are we still emulating the ISDN network? Single-channel ALO communication. Wow, we have gigabit to the desktop. Times have changed, folks. So traffic grows on the internet. Capacity grows. And everything gets much, much better. I'm on my way to the 3D holographic sessions. Take a note, Matt. Things are growing on the internet. Not just capacity, but the number of users connecting, the number of countries connecting. We're growing more than during the dot-com era. How many here have smartphones connected to the internet? Right here in the room. Up. Okay. How many addresses do we have in IPv4? Hi, Joe. Hint? We have more smartphones than we have IP addresses. This network that we've all been using and loving, that some of us have been building, just doesn't work anymore. Right? So, the network will break. And what comes along unless we do something right is a new structure for the internet that emulates cable TV. Small closed islands connecting to the internet through a gateway. Carrier-grade NAT. If you haven't been worried before, you should be. There's an ITF draft now that tells you exactly how bad this will be for all forms of real-time communication. If you think that office NATs and home NATs are bad for IP telephony, it's time to get scared. It's time to get really, really scared. And like Mark said, run like hell. We need to phase this protocol out. We're spending too much money fixing what's broken instead of moving to the current version of the internet protocol. IPv6 is the solution for a global internet that will continue to grow as it's growing right now. IPv6 actually means cost savings for internet telephony. We won't have to spend all this time with NAT traversal, trying to tie together broken networks with more NATs. I have installations where I have 5 NATs in front of my server, not the clients. 5 NATs. Imagine what kind of crazy code I had to put into Asterisk in order for that to happen. IPv6 is really where we need to go. You need to protect yourself, protect your career. You need to learn and play and have fun with IPv6 because that's the cheap and easy solution. That's where you need to be. And there's a lot of talk around just because people, your friends, haven't learned IPv6, haven't played with it. So I can tell you there are no other solutions. We've been working with IPv6 for 15 years, and it's the solution. It keeps growing out there on the internet. There are carriers in the US like Comcast, IPv6 enabling all their customers. We have a whole of Asia where we see IPv6 growing like mad. There's a huge growth in IPv6. And more NATs, carrier-grade NATs. We do not want that. Your customers will complain. You'll get the high-speed internet with real good quality over IPv6. And it's simple, it's just an upgrade from 32 to 128 bits and a few other changes in how we create local addresses. But by God, IPv4 is so old. And IPv6 is the current thing. It's already over 10 years old, it's 15 years old. So this is where you want to be if you don't want to fall behind. I really hope that at next ASTRICOM we will have IPv6 in the Wi-Fi networks. We have at CIPITs and we have at ITF meetings already IPv6 only networks. I can tell you, I can live with that. I can run all my services over IPv6. Most people don't even notice. Your smartphones are IPv6 enabled. Your iPads are IPv6 enabled, and it's on. So protect yourself. Go to ipv6friday.org and read my blog. Get inspired, start labbing. Use a Raspberry Pi to set up a tunnel. That's no cost, and it's a lot of fun. Create new solutions based on this cool internet protocol where everything can be peer-to-peer, with no NATs messing up. Imagine the fun we can have. So come on, right? Don't sit there and think, oh, IPv6 is for tomorrow, next year maybe next year. We IPv6 enable the SIP channel and Asterisk, we IPv6 enable a lot of other parts. Kamailio has had IPv6 since start. Come on. You're falling behind. Fix this. So integrating it from the start will not add a lot of cost, but adding IPv6 when you're in crisis mode and you have everything else to fix that's broken, that will cost money. So to do number 2, integrate IPv6 in every single project from start. Do it now, otherwise there will be high costs in the future and you will fall behind. I already have customers who lost government contracts because governments are now requiring IPv6 and they weren't prepared. The IPv4 pool that's available, nothing. You won't get new assignments. The price for IPv4 is going up. Get there. Okay, that was 2 to-do items. Right? So far, easy to remember. Now we need to speak about quality. Thanks God for cell phones. Users are used to calls hanging up. Oh, what do you say? Oh, right. Oh, sorry, honey, I'm late. Right? They're used to that. We use audio tools made for these lousy networks on our brilliant IP networks. How stupid is that? I mean, come on. There hasn't been enough focus on quality. There has been focus on emulating something built for something else. An ISDN network or a telco network has pretty even quality. That doesn't apply to an IP network. Bandwidth, packet loss, everything changes. Even during a call, you can start a call in one network, move to another while talking. Don't expect your users to stay inside the Wi-Fi network. They will move around, go out to have lunch and still talk. And they want a call to continue. That's not possible, you say. Have you been trying Google Hangouts? You can roam between networks. The Hangout continues. They use RTP. We can do that. If we apply ICE correctly, we can do that. So we can't assume that IP networks work like an ISDN network, and we shouldn't try to emulate that stuff because bandwidth isn't going down. We can do better. We can have, with Opus, we have multiple simultaneous channels. We can have 5-to-1 audio. We can do much better, but we need to adapt during a session because the network is changing. And the solution here is, of course, use a codec that's built for the network you're using. Don't use technology built for another network. Opus is based on experiences from Skype. Skype donated their technology. It's based on experience from the XIF.org speech project. The best engineers with experience of millions and millions of minutes across an IP network built Opus for you. And it's such a cool technology. If you're remotely interested in audio and we read presentations on Opus, this is like a wet dream coming through. It automatically adapts to your network. You go from very low bandwidth compressed audio to CD quality. You can have multiple channels, and it changes during the call. We need Opus. We need this technology, and we need to start using it because it enables, like security, like IPv6, it enables so much more. And WebRTC gives us a lot of updates, right? It gives us new technology we can bring into our voice calls to communicate with WebRTC, but also update SIP for the new generation. We need to start using this. And we need to adapt to a changing climate. When we started, phone calls was the focus. How many here have seen Iron Man? Cool. You see how he interacts with the machines? He talks with the robots. We could very well have a little sign on the robot saying, powered by Asterisk. And that's not telephony, but it's speech, it's communication, real-time communication. So telephony was the app on the telephony network we ported at. Let's start building the new apps. So give your users the audio they deserve. Let's start using Opus. Right? Go to the Opus website, listen to the examples. You'll be amazed. I promise. Okay. I have a few more words, but I just wanted to remind you that I have a new email address if you have any questions after my talk. It's very, very simple. It's much more standardized than my old email address. It's 1994-121-293-901@2012-314-253:27. I will post you a message on the normal channels if my computer changes IP address, right? You're smiling. What's so fun? This is my new email. Oh, yeah. That's wrong. So you might ask, what's wrong with this? The port's closed, of course. We have a carry granite in front. But that's how people use SIP. And this is not the way we design SIP protocols. We design SIP to be a federated network across the internet. Like email, I should be able to call anyone on the net. And this is not really what we're expected to do. This is what happens when we take one network and forces that on top of another without understanding the new network. Let's prove that we're internet citizens, right? That we can communicate across the internet. So I have one message for you. Federate or die. You can stay alone in your isolated island and no one will call you. You'll have to pay to reach us. You don't want that. So with security, we can avoid the whole email crisis. With Opus, we can actually deliver better quality across the internet than in the phone network. And this is how you address on the internet. You have a username in a domain. You're used to that. Talk with your kids. How many phone numbers do they have in their heads? Almost none. They have names. They already communicate with this. And you will be joining me in retirement soon, unless you adopt, right? This is how we communicate on the net. And the phone number is just an alias, a gateway, a bridge to the past. And let's move it to behind the scenes. So this is to-do number 4. Federate or die. Enable your domain. This has been a requirement in Internet 2 for research and academia for many, many years. It's now a requirement for everyone at Astricon. Federate and die. So let's start working. I'm doing quite a lot in these areas. I'm the chairman, the co-chair of the IPv6 working group in the SIP forum, trying to fix some details in running dual stack networks for those who want to keep IPv4. I'm engaged in the ITF in security for real-time communication as well as IPv6. Now I need your support in all of this. I need you to be online and start using this. For Opus, we have a patch. This was actually used and presented at the IETF meeting in Berlin. Lorenzo talked about his Asterisk patch in a plenary with everyone at IETF. Over 1,400 people listening in the room that Asterisk now has Opus support. We need to start using that. Everything is already in the code to handle Opus pass-through. If you add the codec from Lorenzo, you also have the codec to be able to actually transcode to old-time phones that doesn't have Opus. Opus is being added to especially WebRTC and soft phones, soft SIP phones, but coming soon to your hard phones as well. So I gave you 4 things to do. You better remember them. I guess you don't. I have to repeat. Okay, this is your toolbox. We have many different protocols, and we have ourselves, the community. We have made miracles happen in the Asterisk community before. We can make it happen again. We can build, we can take leadership in building a federation, a secure federation using the protocols and the codecs and the stuff we need across the internet. When Mark started, we had XTEL, a central point, a central server. That's telco architecture. XTEL Generation 2 is based on federation using DNS names. A smorgasbord of fun. So here are the 4 to repeat. Security, IPv6, Opus, Federate or die. Will you remember this now? We will call you automatically randomly in the night with using Asterisk. You have to press DTMF. You have to press my email address unless you remember that. Otherwise, we will stream this to all your devices again. And you're not alone. We built all this stuff. We made huge changes. Let's continue doing this together and build a new real-time communication where we get serious and we actually deliver what the users have been expecting us to deliver for a long time, a secure real-time platform for the internet protocols. So let's try to abandon all this proprietary stuff that doesn't interoperate in an open way. You know what I'm talking about. The stuff from Redmond that we can't really inspect. We don't know anything about backdoors because they're proprietary. And that phone company that unfortunately started in Sweden, that they acquired in Redmond. Let's build with open source and open standards. So what's real time? Right? It's here, it's now, and it's together. We can make this happen. So let's start. Thank you.
I think we have some time for questions for Olle. Does anybody have any questions? So everybody's going to accept the Johansson challenge, and we're going to see all 4 things getting done on everybody's systems. Cool. Right? Oh, we have a question.
Oh, we need the microphone for the recording.
So is there a move to have a global black hole list like an RBL for email for real-time communications for SIP and so forth, especially when it becomes multi-peer to multi-peer, where there is no broker in the middle?
That is a very good question. Blacklists in IPv6 is something that the email folks have been discussing and determined it just can't be done. What I really believe we need to do is start using the security systems. So I only accept incoming calls over TLS signaling, where I can verify the certificate. I've written ITF drafts where we actually use something called DANE, that is storing the certificate in my DNS. I sign the certificate, I create the certificate. You trust DNS because it's signed. So when you communicate to Edvina net, you fetch the certificate, and you know where you're calling. I require a client certificate from you. I check it the same way. That way I can blacklist anyone that misuses my service. So I think we have to start from the other side. Start with a trusted network.
Any more questions for Olle? Okay.
I'll be around, so please approach me at any time. And I'll be in the security track, fun enough.